Good morning, everybody. I want to talk to you in this video still about conics, but now we're on to section 2. So we're looking at circles. Circles are not terribly complicated as far as conics go. So this hopefully won't be too long of a video. So let's dive in. Let me start sharing my screen with you. All right, so here we are. Let us first talk about the general formula, the standard form for a circle. So we have, let's see, x. Let me drag my little toolbar out of the way. X minus h squared plus y minus k squared equals my radius squared. So r is my radius. Keep in mind, that means that if I'm given diameter, that equals 2 times my radius. So I'd have to divide my diameter by 2 in order to substitute it back in and find my formula here. Because it is r squared. A lot of people forget that little piece there. And remember, k is always with my y, and h is always with my x. All right, so let's start on an example. The first example I want to do is, let me switch my color up a little bit, and then I'll write it down below. So let's have this be example number 2, even though this is my first one. It's just correlates with some of my students' work better. So I'm telling you that the radius is 6. Yeah, I do crappy cursive sometimes, so keep that in mind. Radius is 6, and we are centered at the origin. So first off, what is the origin? You should hopefully really remember that, but if not, the origin is 0, 0. Awesome. So I have a circle. Just going to do a quick rough sketch of it, right? Center here. And there's my circle. If my radius is 6, it means I go over here to 6, over here to -6, down to -6, and up to 6, right? It shouldn't be too bad. So I also want to note up here that my center is h comma k, just like my vertex is h comma k. It's awesome how they did that for us, right? When I say they, I refer to the old mathematicians that mostly hate you, but sometimes they do something smart like that. All right, so the formula then, I'm just going to take what's up here in blue, and I'm literally going to copy it down here, except with one small change, right? I know my center is at 0, 0, so the h is 0, and y minus 0, because again, my k is 0, because both x and y for my center are 0, and that equals r squared. What's my radius? 6. Okay. And x minus 0 is still just x, and y minus 0 is still just y, and 6 squared is 36. So there's my formula, and that is in, right there, that is standard form. There we go. Awesome. Great job, folks. I'm going to save this, clear this. Now let's start another, right? Let's do what I'm going to call number 5. And I'm going to say that the center is at 2, 3. And my diameter is 1. So let's write down the formula again. I think this is really helpful just to help kind of get you in the swing of things, help you to remember the formula, because things like this are important. You should remember these, especially because most of my students are going on to pre-calculus and then calculus, and you need to know the formulas for circles for that, especially when you start getting into disks and stuff, finding volumes in calculus. All right, I was given my center, right? Remember, these are in alphabetical order, h comma k. It's sweet that way. So I have x minus 2 squared plus y minus 3 squared equals radius squared, but I don't know my radius. So I'm just going to write radius squared right there. But I do know my diameter is 1. And remember, diameter is 2r. So 2r equals 1. If I divide both sides by 2, I know my radius is 1/2. Okay. Well, now I'm going to substitute that up there, right? Delete that and put in my 1/2. Okay. Now I am going to have to actually do a little bit more math, right? So far, I've just been plugging things in, not even making any changes, right? So 1/2 squared, that's the same as 1/2 times 1/2. Do that off to the right, because I like showing these little steps, right? 1 times 1 is 1. 2 times 2 is 4. All right, that's it, folks. That's it right there. Done. Awesome. If it were a proof, I'd maybe do a little square and fill it in. Awesome. Go team. Clearing this. Let's do another. And as Emerson, one of my former students, would always say, let's do a harder one. So let us do number 7 now. Number 7 is going to be a little bit more tricky. So I just want to say that up front because I know so many of my students become frightened with this kind of stuff. And I think if you go in knowing it's going to be a little bit of a challenge, it's okay. You know, just don't be afraid of it. I mean, worst case scenario is get a math problem wrong, right? Who hasn't done that? So I need to get this into standard form. Oh, man, I keep spelling standard wrong. I keep wanting to say standard. There we go. Form. Okay. So this really means I'm completing the square twice. Complete the square 2 times. I have to do it with my y's and with my x's. So the first thing I need to do is I need to separate those pieces. I'm going to put my x's all together. X squared minus 10x. Then I'm going to put my y's all together. I have a y squared minus 10y. And then I'm just going to leave the 25 alone for a little while, right? He's just hanging out, just chilling like a villain. All right. Now I'm going to stick with green and I'm going to stick with the x's, okay? So just like I've done before, we've completed the square before. I'm going to wrap them up in parentheses. I'm going to have to add a number here, but then I also have to subtract a number away, right? So some of my students hate this. I like to do it all on the same side, but you can also move things over to the other side. I'm actually going to go back a step. Let us subtract this 25 over and put it over here. So now this equals 25. We'll do it that way. I think less of you will have struggles that way. Okay. All right, so we have this. And then we're going to switch to black. Okay. And then plus y squared minus 10y plus, I'm going to give myself a space. And then that equals 25. But we have to remember, right, that I added a green number and I added a black number. Okay, I added the green one from my x's, I added the black one from my y's. Excuse me. So it is important that if I added it on the left side, I have to add it onto the right side. So let us now discuss what goes into those blanks. What goes into this blank is always going to be my b term, or just with a single solitary x, and I take that number, I divide it by 2, then I square it. So negative 10 divided by 2 is negative 5. Negative 5 squared is, 25. Good job. And that goes on both blanks, right? If I added 25 to the left side of my equation, because remember this didn't exist, so then I have to add 25 to the right side of my equation to keep both of those things in balance. Okay, most of the world is all about keeping balance, right? You've taken chemistry, or you will. All right, so now let's go over it and let's look at black with yellow. So it's actually the same thing here. So negative 10, I divide it by 2, and then I square it. So that's going to get me my same number. I have to add that over to the right side of my equation as well. Okay, so we've come a long way. That's awesome. Let us switch to red again. I'm going to factor each set of these parentheses. X minus 10, x squared minus 10x plus 25 is x minus 5 squared. Okay, because I have to multiply to get me 25, which could be positive 5 and positive 5, or negative 5 and negative 5. But I have to add up. I have to add to get this negative 10, and I have to multiply to get that 25. So just keep that in mind when you're doing this. It also always happens to be the negative 10 minus 2. That will always get me this number down here. Now I'm going to do the same thing with my y's, and it ends up being the exact same thing. Then my right side of the equation, okay, all of these things, it's going to come down, and it's going to be 75. Sweet. But now let's also identify some important things. I almost always want to know my center when I'm looking at a circle. It's going to be 5, 5. Remember, x part comes first, and then y part. And because they were both in parentheses, I want the opposite of that number. Then let us look at our radius. Well, it's going to be the square root of the 75, right? Because r squared equals 75. That came from my equation, okay, the general form of this equation. So I need to square root both sides. I'm going to do this in a slightly fancier way. Please don't be frightened. So square root of 25 times 3. We all agree this 25 times 3 is going to get me 75, right? I hope so, because you can't respond. Anyway, leave a comment below if you don't understand that part. So now I can split this thing up. And this is only to make it so that I don't have to use a calculator and I get a pretty answer. All right, so now I'm down here. I can split this up to the square root of 25 times the square root of 3. So I can split that square root up as long as everything inside of it is being multiplied. So what is the square root of 25? Straight up 5, yo. Nothing else. I feel like I need to say yo after saying straight up. I don't know. That's just me. And then the square root of 3 does not simplify. 3 is a prime number, so there are no simplified version of that. So my radius I would write as 5 square root of 3. There's, of course, a decimal equivalent, but I prefer not using a calculator if I can help it. So this is the answer to this problem. It would actually be everything down here in red. Because, of course, if I'm asking you for the formula, I also need to know about the center and the radius. So let's get rid of this screen. And let's do one more. This one's going to be, excuse me, a little bit of a tickle. I didn't grab myself water. Let us solve what is called a linear quadratic system. So x squared plus y squared minus 16 equals 0. And I'll switch colors up. And we have x minus y plus 4 equal 0. So I do just want to point out that this black one down here is the linear one, and the red one is the quadratic. Okay, so the top one, the red one, would create a parabola, and the black one would create a line. The only reason it's important to know that is so that if I ever say a circle or a linear and a circle formula or anything else like that. I mean, quadratic, I guess, because we have exponents here. But if I said two linear systems or just a linear system of equations or a quadratic system of equations where both of them are quadratics. We've done that before, actually. So this is actually reviewing here. So let's start. Down here on the black one, I'm actually going to solve this one for x. So I'm going to add my y and subtract my 4 to both sides. So I end up with a positive y and a negative 4 on the right side, and x stays on my left. The red one, I'm actually going to leave it just as it is. Not going to tweak it at all. So x, remember, equals y minus 4. I'm going to take that and I'm going to substitute it in over here. Y minus 4. I'm actually going to rewrite this a little bit higher up. I'm going to be needing a lot of space. You will too, so keep that in mind. Y minus 4 squared. Actually, let me not write that too in a different color, because that was part of my original red formula, right? Just draw a little line separating this. Okay. So all I've done is I've solved for x in my equation 2, and I've substituted that into equation 1. And now I'm going to simplify this equation, see what we can get. I'm going to do this all in blue. I'm not going to show you the foiling of this, but you do have to foil, and you would end up getting y squared minus 8y plus 16. That all comes with a set of parentheses being squared. And I'm still left with the plus y squared minus 16 equal 0. Now everything's on the same side. Everything has y's in it. Let's combine like terms. There's this parenthesis, but I'm just adding stuff after it. So the parentheses serve no significance anymore. Y squared plus y squared gets me 2y squared. I have a negative 8y, and then this 16 and this 16 cancel. Plus 16 minus 16, just 0. Equal 0 now. So a lot of people would start to maybe add the y over, no go. All right, we want to actually factor this. So I'm going to factor using the GCF, or the greatest common factor. What are these things? What's the greatest thing that these both have in common? And it ends up being 2y. So I've factored that greatest common factor out. And now I'm actually going to set each of these pieces equal to 0. So 2y equals 0 and y minus 4 equal 0. I have to factor it and then set each piece equal to 0 because I have a quadratic equation over here. So I have an x squared and a y squared and a y. I have to find each of those. Because it's a y squared, I know I'm going to have two answers. Divide both of these by 2, so y equals 0. And I'm going to add 4 to both sides, so I get y equals 4. This is significant, right? I have two answers. Now I'm going to have to find both of their corresponding x values, because I'm going to write it way over to the right side of my screen just so you know where I'm at. I'm going to have two answers. They're going to be coordinate points because we're really looking at where, I'll do this little graph above, right? I have a circle centered at the origin with a radius of 4. You'll get better with that with practice. And then you have a line that would be x plus 4. So you have a line that's up here. Those two lines, or those two graphs cross at 2 points. So I should have two answers. Now, that's not always the case. When a circle and a line meet, I might only touch at 1 point or no points at all. And so I know both my y values. I know that one of them's a 0 and one of them's a 4. So I'm going to use this equation here. And I'm going to use burgundy to write it. X equals, and let's find the case where I plug in a 0 for my y value. So x equals a -4. That goes into this top answer, because when y is 0, my x equals -4. Now I need to figure it out for the bottom coordinate point, right? So x equals, and I'm substituting in what 4 is in this case over here, and that's 4 minus 4. So x equals 0. That corresponds to this point. So I have a lot of students that kind of mix and match those two things. Be careful that you're paying attention to which x goes with which y, or which y goes with which x if you solve for x first. I think that's it. That's all I have to go for. Let us exit the screen share. So this was talking about circles. Again, they're not terribly complicated. This is still a part of conics. So if I took that weird cone-looking thing and I sliced it completely horizontally, this is the kind of shape we get as a perfect circle. If we cut it slightly at an angle, we start to get something like an ellipse, and I believe that's what we're going to discuss next. So it's really a circle that we're going to just stretch a little bit. Kind of interesting, pretty fun. We end up, if you think about like two parabolas coming together, that's not a bad way of thinking about it. So hopefully this was helpful. If it was, hit that like button down below. Subscribe to the channel if you want to see more like this, and so I can get my subs up, right? Got to start trying to prove to people that this channel is actually worthwhile. So hit or type in a comment below if you're interested in telling me anything. I'm always interested in hearing new things. So if you have good ideas for me to maybe improve these videos, please let me know. And I hope all of you have a phenomenal day. And remember to do math carefully and with enthusiasm. Bye, everybody.